dear students, welcome back to my class. In the series of learning programming in C, in the previous video we discussed about calloc function with a programming example. In today's video we will discuss about realloc in C. So what is this realloc? How to use this realloc? Let us understand this with a programming example. Realloc in C. Realloc means reallocation of memory. So we are going to reallocate the memory. Using calloc and malloc, we allocate the memory. Once we allocate the memory using calloc and malloc, the allocated memory can be reallocated. Means I can increase the size of the memory or I can decrease the size of the memory. So realloc in the sense reallocation of memory. We can resize the memory in the sense we can increase or decrease the size of the allocated memory. So using calloc and malloc, we will do dynamic memory allocation. The allocated memory can be reallocated. Means we can increase the allocated memory or we can decrease the allocated memory. So this reallocation. So how to reallocate? So we have to use the function realloc. The syntax is like this. Realloc, it is going to return a generic pointer. Then it has to reallocate the memory which is already allocated by calloc or malloc. So that base address will be held in the pointer. So that pointer followed with the new size that what we need to reallocate. So for example, using calloc or malloc, we have allocated 5 or we can just say 5 bytes of memory or 10 bytes of memory. It depends. But later we decide we have to allocate few more memory. Then what we can do? With that existing memory itself, we can do the reallocation with the help of this realloc. So it is reallocating. Realloc also returns a generic pointer. So realloc the memory allocated by the pointer, existing pointer that has dealt with calloc and malloc. And the new size we need to mention. So for example, we have an integer pointer. So we are allocating the memory using calloc. So the calloc has allocated 5 bytes of memory, or it depends upon say I want to store 5 elements. It decides the size based on this data type. Say for example, I have 2 bytes for integer with respect to 16-bit machine. If it is 32-bit machine, it may be 4 bytes. So let me take 2 bytes. So I say 5 into 2, totally 10 bytes of memory will be allocated using calloc. Hope you all know how to use calloc. In the previous video we have discussed about calloc. Please do check out the playlist. So it is the size 5, size of int. So I am allocating the size of int means 2 bytes of multiple blocks of memory of same size will be allocated, and I am going to typecast that to integer, and the base address will be held in this PTR. So PTR will have 1000. It is pointing to this base address. Now what I'll do, so this 5 elements that what I am going to store, the memory is not sufficient for me. 10 bytes of memory is not sufficient for me. I want to store few more elements. And what I'll do? I'll reallocate. So how to use that? Realloc. As it is going to return a generic pointer, I need to typecast that. Then realloc the memory allocated by PTR. So PTR has already allocated the memory to store 5 elements. I want to store few more elements. Plus 2 more elements I want to store. So totally I say 7 into size of int. So I just say 7 into 2. So I just say I want to store 7 elements. So 14 bytes of memory is required. So that base address has to be written to a new pointer or to the existing pointer. So now what happens here? If it is possible to allocate the memory there itself, then here what happens? The memory will be extended here only. It says I want to store 7 elements of the size int, means 2 bytes into 7, totally 14 bytes I need to allocate. So what the system may do, it may extend the existing memory itself. So if possible, the memory gets extended with the same base address and content remains same. Understand this carefully. Contents remains the same and the memory can be extended with 4 more bytes. So I may store next two elements say 60 and 70. So here what happens? If it is possible to extend, it will extend the memory and the same base address will be written. I can store that in the same pointer or into a new pointer. So now PTR1 gets the same base address if the memory has extended. If not, what it will do? It will allocate a new memory to store how many elements? 7 elements. 7 into 2, 14 bytes of memory it has to allocate. 1, 2, 3, 4, 5, 6, 7. A new memory will be created. So something like the address, base address 2000. And all these data will be copied, existing data. 10, 20, 30, 40 and 50. Then I can store the new value 60 and 70 and this new base address can be stored in PTR1. So you can also print that address. If you print PTR, you will get the base address, same base address. If the memory is being extended and the new memory, if you copy to the PTR1, if it is extended, you get the same address, 1000. If not, it is going to, if not possible, if the memory is not possible to be extended, then it is going to allocate a new memory. It gets reallocated, content gets copied and it is going to return new memory address. So this new memory address will be written. So here I may have a new pointer by name PTR1 which is pointing to this base address. So it depends upon the machine. The memory can be extended, then the same base address with same content, then add new values. If not, allocate new memory to store this new data, then copy the previous data into that new allocated memory and return that base address to the pointer. So while coding, if you try to print the value of PTR and PTR1, if the PTR1 is getting the same address, then memory is being extended. If PTR1 is not getting the same address, new address means the memory is not extended, it is reallocated. So new memory is allocated, all the data will be copied to that. So this is what with the case of realloc. And if we try to decrease, obviously the data will be lost. So if we increase, the data will be not lost. It may extend the memory or it may allocate a new memory and all the data will be copied to that new memory and that new address will be returned. As the base address, new base address will be returned to the pointer. And we can check out that also by printing the pointer value. If I get the same address means memory is extended. If I get a new address means the memory is reallocated. But the data remains the same because it is going to copy the content. But if you decrease the size, obviously the data will be lost. And sometimes there may be some scenario wherein which the realloc may not be able to allocate the memory. In such case, it may return null also. So let us understand all these things with an example program. So here we have the complete program to understand this realloc. So let us have two pointers. One is PTR, the other one is PTR1, n and I supporting variables. Enter the value of n. So as usual, scanf and store the value in n. So n value I have taken as 3. Now I am allocating the memory using calloc. So typecast to integer n. So it is 3, size of integer. Size of integer. So let us say 2 bytes. So 3 into 2. So totally 6 bytes of multiple blocks of memory of same size will be allocated with calloc. And the base address will be held in PTR. So PTR, say base address is 1000. PTR is having 1000. It is pointing to the base address. I'll say enter the values as usual. We all know how this PTR plus I is going to work. If you have any confusion with this, please check out the previous video of Kellogg or Belloc to understand this PTR plus I. So we will accept the values at 10, 20, 30. Then let me enter a new size. So I am going to reallocate the memory. Kellogg has already allocated the memory. Now realloc is reallocating the memory. So let me give the new size as 5. Now, as usual, enter new size, scanf, ampersand of n. So n is 5. Now I say realloc, typecast that to integer, reallocation for the already allocated memory which is pointed to by the pointer PTR. So PTR is pointing to 1000. So I need to reallocate this. To how many bytes I need to allocate? So n I have given as 5 into size of int means 2. 5 into 2, totally 10 bytes. Already we have 6 bytes. So 2 more values we need to store. So now it depends on the machine. The memory can be extended or it can be reallocated freshly. New memory can be allocated. Let us assume that the memory has been extended. So from the same base address, the memory is extended. So I say 5 into 2, how much bytes? It is 10 bytes of memory I need to allocate. So 4 more bytes. 4, 5, 6, 7, 8, 9, 10. So 10 bytes of memory I have reallocated. Means memory is extended and it returns the same base address to PTR1. So I have one more pointer now. Say PTR1 which is also getting the same address. It is returning the same address, same base address. So PTR1 is also having 1000. So it is also pointing to the same location. Memory is being extended. Then you can also check that whether it is extended or a new memory is allocated. We can just check that with the values that what we have in PTR and PTR1. So I can just say PTR equal to percentage %d, PTR1 equal to percentage %d. Print PTR means it is the value that which was already allocated, memory which was already allocated. So PTR means 1000. PTR1, if the memory is extended, then I get the same base address. Contents remains the same. Only the memory gets extended, contents remains the same and the same base address is returned. So even PTR1 means it is going to print 1000. If the memory is not extended, then a new memory will be reallocated. All the contents will be copied to that. A new memory will be allocated. Say new memory to store how many values? 1, 2, 3, 4, 5. Say the base address is 2000. The content will be copied here and this new base address will be stored to PTR1. Right. And the memory allocation will be done in heap memory. Pointer allocation will be done in stack memory. All these things we have already dealt in the previous videos. So I can just print those values. Then if I try to print the values, after this you can also accept new values if required. If not, you can simply print the values. Memory is extended now. So here 2 more space will be created, but we have not filled values. If you want, you can fill the values. So the loop starts, I say asterisk PTR plus I means, see look at here. I have to say PTR1 plus I. So here I am writing so that to make you understand, we are referencing PTR1. New memory is the same memory but it is extended, but we don't know whether we are going to get the same memory or a new memory. So but we have to refer to the PTR1 because we are reallocating the memory. Reallocation of the memory can be done with the same memory. Memory can be extended or a new memory can be allocated. So that address will be held in PTR1. So in the PTR1 we will have new address. Means here what we should say, we have to say asterisk PTR1. So asterisk PTR1 plus I. How this asterisk PTR1 plus I is going to work? You can please check out in the previous video, Kellogg and Belloc. So here we have to write PTR1 so that it points the extended memory, the new extended memory. Then I get 10, 20, 30 and here as it is Kellogg, you get 0. If it is Belloc, you can just get some junk value. Then at the last we need to say free PTR1. Then close the main program. So hope you have understood this reallocation. The two things that what you have to understand with realloc is going to reallocate the memory. It increases or decreases. If it is increasing, it may extend the same memory, same base address. Or it may allocate a new memory, all the data will be copied and a new base address will be written. So let us see the execution of this. Here we go with the program to understand the realloc. So realloc means reallocation. So we have two pointers here. One is PTR, the other one is PTR1 as usual. We'll enter the number of values. So n value will take and we'll allocate the memory using calloc of size n. Then we'll accept the values. Then we'll enter a new size. Then we are going to reallocate for that new size with the existing pointer PTR. So it is new size means 5 into size. If the memory is allocated there itself, then the memory gets extended and the same base address will be written to PTR1. If not, a new memory will be allocated. So when the memory is being extended, the same base address will be there and the content will also be there itself. And new memory will be added, means memory will be extended to store the new data. But if the memory is not being extended, then a new memory may also be allocated. Then a new base address will be written to PTR1 and all the data will be copied to the new memory allocated. And one more point to say, the memory, if it is allocated freshly, then the data will be copied to that new memory and that existing memory will be deallocated. So this PTR will be deallocated. So here if I use, in case of PTR, if I just say null, then this realloc acts like malloc. And here in place of size of int, if I use null, then it is going to free the pointer. So here I can use realloc in different ways. So when realloc is used, it extends the memory. It is going to reallocate the memory. The same memory can be extended, then the same base address contents remains there itself. If the same memory is not extended, then new memory will be allocated, all the data will be copied to that new memory and that old memory will be deallocated. That point you need to remember. Old memory will be deallocated, the data will be copied and the new base address will be written. So let us see this program, that whether it is extending the same memory or it is allocating a new memory. So we can print that with this PTR equal to %d PTR1. So we can print the value of PTR and PTR1 so that we can get to know whether the memory is extended or a new memory is allocated. So if it is extended, same base address. So PTR and PTR1 will have the same address. If not, then new address will be allocated, data will be copied and the old one will be deallocated automatically. We need not free it. Then a new address we are going to get in PTR1. So we'll see how the machine is allocating. Then we can also take new values or we can simply print the existing values. As the memory is extended, I say the loop will go up to n. So if I just say 3 values I've accepted, then later I say 5 values I'm going to accept. Then as we have allocated with realloc, I may sometimes get 0 or I may get junk value also. Right. So first 3 values, whatever I have accepted, that value will be printed and the remaining memory allocation we have not initialized. So we may get 0 or we may get junk value. So let us save this program and execute this program. Run the program. Enter the number of values, I just say 3. Then enter the values, I say 10, 20, say 30. Enter new size, I'll say 5. See, PTR 129.16120 and PTR1 also 129.16120 means the memory is being extended. So the same base address for both PTR and PTR1. Entered values are, see, 10, 20, 30 and memory is extended, right? So the remaining 2 values will be 0. So this is how the realloc is going to work. And see, here we say free PTR1. We are not saying PTR because PTR will be deallocated by itself. So this is how PTR1 will be freed and I am going to print the values 10, 20, 30 and 0, 0. See, after this you can also accept 2 values and then you can print. You can just check out that, it's an assignment for you. After this, what you can do, you can enter two values and then finally you can say the entered values, you're going to get it. So that's all for today's video. See you in the next video. Till then, take care. Bye bye.